Welcome back to our YouTube channel. If you are new here, make sure to subscribe and hit the bell icon to stay updated with our latest content. Behind the veil of legitimate software downloads and online purchases lurks a shadowy underworld. Here, digital pirates roam free, peddling cracked copies of paid software like precious contraband. Software piracy, a silent epidemic, costs companies billions annually and exposes users to a myriad of risks. But how does this illicit trade thrive? How do these digital buccaneers circumvent the sophisticated security measures put in place to protect intellectual property? The answer lies in a combination of technical prowess, cunning exploitation of vulnerabilities, and a relentless drive to unlock the secrets hidden within the software's very code. This is the world of software cracking, where hackers, driven by a thirst for knowledge, notoriety, or simply the thrill of the challenge, dedicate themselves to dismantling the barriers that stand between them and free access to paid software. Their methods, often ingenious and always evolving, expose the vulnerabilities inherent in even the most secure systems. Join us as we delve into this clandestine realm, uncovering the secrets of how hackers crack paid software and exploring the implications for both software companies and everyday users. Hackers, like master craftsmen, employ a variety of tools and techniques to ply their trade. Some are simple, while others are incredibly complex, requiring a deep understanding of software architecture and security protocols. But all share a common goal: to bypass, disable, or manipulate the mechanisms that enforce software licensing and control access to paid features. One of the most common tools in a hacker's arsenal is the disassembler. This ingenious piece of software allows them to break down a program into its assembly language, the low-level code that directly interacts with a computer's processor. By analyzing this code, hackers can identify the routines responsible for checking licenses, verifying activation keys, or enforcing other security measures. Another powerful weapon is the debugger. This tool allows hackers to execute a program step by step, monitoring its behavior and identifying the exact points where security checks occur. By setting breakpoints and examining the program's state at critical junctures, they can pinpoint vulnerabilities and devise strategies to exploit them. These are just a few examples of the many tools at a hacker's disposal. Their ingenuity knows no bounds, and they are constantly developing new and innovative methods to circumvent even the most sophisticated security measures. Key generators, or keygens for short, are small programs designed to generate valid license keys for paid software. They work by exploiting flaws in the software's licensing algorithms, essentially creating master keys that unlock the full functionality of the program without requiring a genuine purchase. Imagine a software program using a simple mathematical formula to validate its license keys. Perhaps it multiplies the user's name's numerical value by a fixed number and then adds the current date. A keygen, in this case, would simply reverse engineer this formula, allowing it to generate valid keys for any username and date. Of course, modern software uses far more complex licensing schemes, often involving online activation, hardware identification, or other sophisticated measures. However, determined hackers can often find weaknesses in these systems, allowing them to create keygens that can unlock even the most seemingly secure software. The use of keygens is widespread, particularly for popular software titles with large user bases. They are often distributed through underground forums, file-sharing networks, and other shadowy corners of the internet, offering a tempting alternative to paying for expensive software. Patching in the context of software cracking involves modifying the program's executable file to bypass or disable security checks. This can be done by altering the program's code directly or by injecting new code that overrides the original instructions. Think of it as a digital band-aid, covering up the parts of the code that enforce licensing restrictions. Hackers might, for example, locate the specific instructions that check for a valid license key and replace them with instructions that always return a positive result. This effectively tricks the software into thinking a valid key is present, even if none exists. Patching can be a delicate process, as even a minor error in modifying the program's code can render it unstable or unusable. However, skilled hackers can make surgical alterations to a program's inner workings, effectively neutering its security mechanisms without leaving a trace. Patch software is often distributed through the same channels as keygens, offering users a cracked version of the software that requires no additional steps to activate or unlock. This ease of use, combined with the perceived risklessness compared to keygens, makes patching a popular method for distributing pirated software. Section 5. Reverse engineering. Delving into the software's DNA. Reverse engineering represents the pinnacle of software cracking, requiring a deep understanding of programming languages, operating systems, and software architecture. It involves dissecting a program to understand its underlying logic, data structures, and algorithms, essentially recreating the blueprint from the finished product. This meticulous process allows hackers to identify vulnerabilities, understand how security mechanisms are implemented, and ultimately find ways to circumvent them. It's like taking apart a complex machine to see how each component works, then using that knowledge to disable safety features or modify its behavior. Reverse engineering is a time-consuming and intellectually demanding endeavor, often requiring teams of skilled individuals working collaboratively. However, the rewards can be significant, as it allows for the creation of highly effective cracks, keygens, and other tools that can unlock even the most secure software. While reverse engineering can be used for legitimate purposes, such as security research or software interoperability, its use in software cracking poses a significant challenge to software developers and highlights the constant arms race between those who create software and those who seek to break it. Section 6. The high cost of software piracy. A look at the fallout. The consequences of software piracy extend far beyond the loss of revenue for software companies. It's a multifaceted issue with ripple effects that impact the entire software ecosystem, stifling innovation, increasing cybersecurity risks, and ultimately, harming users themselves. For software developers, piracy translates to lost revenue that could have been reinvested in research and development, leading to fewer innovative products and slower progress in the industry. It disincentivizes creativity and undermines the hard work and ingenuity that goes into building high-quality software. Users, too, pay a price for using pirated software. Cracked software often lacks essential security updates, leaving systems vulnerable to malware infections, data breaches, and other cyber threats. Moreover, using pirated software is illegal in many jurisdictions, putting users at risk of legal repercussions. The true cost of software piracy is difficult to quantify, but its impact is undeniable. It's a global problem that demands a multi-pronged approach, combining legal action, technological advancements, and user education to create a safer and more sustainable software ecosystem. Section 7. Notorious hacks when software giants fall. The annals of software piracy are replete with stories of daring hacks and high-profile victims. From operating systems to productivity suites, no software is truly immune to the persistent efforts of determined crackers. These real-world examples serve as stark reminders of the constant battle between software developers and those who seek to circumvent their protections. One such example is the infamous cracking of Windows XP. Despite Microsoft's best efforts to secure its flagship operating system, hackers exploited vulnerabilities in its activation scheme, allowing users to install and activate the OS without a genuine product key. This widespread piracy led to significant financial losses for Microsoft and highlighted the challenges of securing software in an increasingly connected world. Another notable case involved Adobe Photoshop, a professional image editing software suite widely used by graphic designers, photographers, and artists. Despite its high price tag, cracked versions of Photoshop flooded the internet, making it one of the most pirated software titles of all time. This rampant piracy not only impacted Adobe's bottom line, but also created an uneven playing field for legitimate users who paid for the software. These high-profile hacks serve as cautionary tales, reminding us that even the most sophisticated security measures can be circumvented with enough time, resources, and determination. Section 8. Staying ahead of the game. Cybersecurity in a world of threats. In this ongoing battle against software piracy, developers are constantly innovating and refining their security measures to stay ahead of the curve. The cat-and-mouse game between security experts and hackers is a continuous cycle of innovation and adaptation, with each side striving to outmaneuver the other. One approach involves implementing more robust licensing schemes such as online activation, cloud-based licensing, and hardware-based authentication. By tying software licenses to unique hardware identifiers or requiring online verification, developers can make it significantly more difficult for hackers to create generic cracks or keygens that work for all users. Another key strategy is to focus on code obfuscation, a technique that makes software code more difficult to understand and reverse engineer. By encrypting sensitive sections of code, using misleading variable names, or employing other obfuscation techniques, developers can make it significantly more challenging for hackers to decipher the program's logic and identify vulnerabilities. However, cybersecurity is not solely the responsibility of software developers. Users also play a crucial role in protecting themselves and their data. Section 9. Protecting your digital kingdom, a call to arms. In the digital age, cybersecurity is no longer a luxury but a necessity. Always obtain software from legitimate sources. Keep your software up to date. Educate yourself about cybersecurity best practices. By working together, we can create a safer digital world.